Before we continue to approve this to do a canary deployment into production, let's look at GitHub Actions. Let's go back to the pull request. And we've already merged this pull request in, but we can still see the checks that were executed. You'll see I have a check called Slacker. Let's click on that. Now the log looks very similar to Azure Pipelines, and that's because the GitHub Actions runner or agent is a fork of the Azure Pipelines agent. However, instead of running actions from Azure Pipelines, we're running actions from GitHub. In this case, we're sending a Slack notification to a Slack channel. Looking at the logs, I can see the command that was used to send that message to my channel. Let's see how I defined this action. We'll go back to the code on the repo. And you'll notice I have a .github/workflows folder. This is where I can place actions to automate workflows. I only have a single workflow present. Each action is going to have a name, in this case Slacker, and then a list of triggers. This particular action is triggering on push or pull requests. And then there are some jobs. I've got a job called build, which runs on Ubuntu latest. Again, you'll notice the YAML is fairly similar to Azure Pipelines. My first step is an action to check out the code from the repo. Secondly, I run an arbitrary script, in this case just an echo. The next step is a Slack notification for the commit. I'm supplying some environment variables, including a variable called secrets.slack_webhook. This user statement lets me specify which action I'm actually executing. The with statement allows me to pass arguments in. Again, I'm using some metadata like GitHub event name and GitHub actor to fulfill the particular step. Let's have a look at where this action comes from. I'm going to grab this users and open up a new browser to github.com and paste in the rest of that action specification. You can see it takes me to a repo. All GitHub actions are modeled inside of repos. Let me open up Slack so you can see that message in Slack. I'll click on my Parts Unlimited channel, and here you can see a series of Slack messages that have been posted from my action. There's one more thing we want to cover here, and that's secrets. Let's go back to our repo. Let's take a look at the Slack action. We're including a Slack webhook, which includes a token for authentication. So it's some information we want to keep secret and don't want to hard code in our repo. Well, if we come up to settings on our repo and then click on secrets, you'll see the Slack webhook secret that we have. We can add new secrets by specifying a name and a value. These are encrypted and stored securely on GitHub and are available for use within any action. Of course, there are a number of other actions that we can use to build, test, and deploy code. If I click on Actions, it'll take me to the Actions section, which we've seen before. Let's click on New Workflow. This will bring me up a list of starter workflows. GitHub has detected some of the languages that are in this repo, like Node.js, and is suggesting a workflow that will compile and test Node applications. There are hundreds of starter workflows and actions from the community. We can also create our own actions, either using Node.js or TypeScript, or even Docker containers, so that we can package up our action as well as its dependencies. I'm not going to do a deep dive in actions now, but wanted you to see an idea of how actions can augment your workflows and your CI/CD. Let's go back to our pipeline. We can see that we've passed the build and test sources stage. We've also passed the deploy to dev stage. There's one difference between this build and the previous build from our PR, and that's SonarCube Integration. Let's open up the build and test job. And this time, instead of skipping the SonarCube tasks, the SonarCube tasks have been executed because we're building off the master branch. Let's open up SonarCube so we can see the analysis of our project in SonarCube. I'll click on Parts Unlimited, which is the project that we have put our analysis to. And this is the dashboard. We can see that there are 33 bugs and 2 vulnerabilities and so on. Now the team can address these issues and track their technical debt through SonarCube. One other important note is that the quality gate status is passed. Let's go back to the pipeline and just verify that this was actually checked in the pipeline. This task that we're on here uses a REST command to query the API of SonarCube and verify that the quality gates have passed. This JSON here is the result of that query, and we can see the status is OK. This means that we've successfully passed all the quality gates. If we'd failed any quality gates, this step would have failed, and the build would have failed. Let's go back to the stages for this release. Now, deployment to dev occurred automatically because we did not have any approvals. However, as we deploy to production, we've defined approvals, as we saw in a previous video, on the environment. Let's click on this waiting to see the check. I'll click on review, and here we can see who needs to do the approval in order to deploy into this production environment. So what's going to happen when we deploy into production? To answer that, I'm going to open up a quick slide to explain how slots work on Azure Web Apps. In order to understand what's going on with our slots, let's consider this scenario. We have a partsunlimited.azurewebsites.net site. Users enter that URL in and are directed to the compute that serves this web page. Within this web application, under the hood, we actually have a traffic manager. Now, when you create an Azure Web App, you don't really see this traffic manager, but it's there all the same. And that directs traffic to a virtual IP or VIP slot, which by default is called the production slot. That production slot, or any slot, can have app settings on it. In this case, we have an app setting called slot, which in this case has the value of prod. And we have another app setting called foo with the value of bar. We also have version 100, for example, deployed. These are the actual files that are being served by that web app. That web app also has a connection string to an Azure SQL database. Now, when we do canary testing, we don't want to have users have to enter a separate URL. So what we can do with an Azure Web App is we can use what's called a slot. Now, the slot has multiple uses. The first one is zero downtime deployment. You can see that Traffic Manager here is directing zero traffic to that blue slot. which means that when we're copying new files and new versions of our applications to that slot, even if the slot is down and unavailable or broken, it doesn't matter because no user traffic is being routed to that slot. This slot also has its own app settings. You can see the value of foo is zap, and the value of the slot setting is set to blue. We've also made the slot app setting on both slots sticky so that when we do slot swaps later on, that value goes with the slot swap. Once we've deployed files to that slot, we can start directing traffic there, which gives us zero downtime deployment. We're going to take it a step further and do some traffic routing for canary testing. Once we've deployed to the blue slot, we're going to instruct Traffic Manager to direct 20% of all traffic to that blue slot. Remember, this is from a single URL. Traffic Manager directs users, in this case every fifth user or 20%, to the blue slot. That traffic is also session sticky, so that once a user has been directed to a slot, that user remains on that slot for the remainder of their session. Now every fifth user is on the blue slot code, which is 101. At this point, you can see why telemetry is important. If we have no way of measuring what's happening on those slots, we won't know whether this experiment is a success or not. So hopefully we have some good telemetry, in this case we do through application insights, that we can use to monitor what's happening on those slots and determine if this experiment is successful or not. Let's imagine we decide that it is successful. All that we have to do is do a slot swap and then adjust the traffic to 100% onto the new prod slot. This operation is instantaneous because it's just an update of the VIP inside of the Azure Web App. So we don't have to copy files or do any more deployments. Of course, if the experiment was a failure, all we have to do is revert the traffic so that all 100% of traffic goes to the original prod slot. Let's see this in action. Let's click on Approve to approve deployment to this environment. Now that is going to take a couple minutes to run, but while that's running, I'm going to open up the Azure portal. I'm going to click on Dashboard to go to my dashboards. And you'll see that I'm here at the Parts Unlimited Monitoring dashboard. I've created these visualizations from the Application Insights telemetry that's going to Azure from our web app. In the next video, I'll show you exactly how I set up Application Insights and how we've added custom telemetry. For now, this is the result of that telemetry. Now you'll notice that there's performance telemetry, like performance buckets, as well as what I call business telemetry. For example, sales by category. There's two widgets which are really important for this demo, and that's events by version, as well as blue-green oil breakdown. The events by version is showing us how many events there are for the current version of our application in our web app. You can see over the last hour we've had 174 events from version 10032, which is the last version that was deployed to our prod site. If we look at the blue-green oil breakdown, we'll see that the prod slot, or the green slot, has had $2,000 of sales. The reason the color is blue is because that's the default color for a range for these widgets. Let's go back to our pipeline. If we click on the tasks, we can see the live logs. I'm going to fast forward a little bit, but before I do that, I wanted to show you how we're executing JMeter tests to simulate some traffic. Let's go back to our code. I'm going to scroll up to the JMeter folder in my solution. Let's click on cart test JMX. This is an XML file that was generated through the user interface for JMeter. This includes querying the site by adding items into the basket. I've got a run.sh script which lets me run these tests as part of a Docker container. You can see I'm using a docker run command to run those tests. Let's see how they're executed inside of the pipeline. If I click on the deploy and route job YAML file, you'll see that I have a JMeter job. This JMeter job is executing the test.sh command, which is going to spin up a Docker container and run the JMeter tests. The Docker container has JMeter installed as well as all the dependencies. We can see that container if I scroll up and click on the run.sh script. The image we're using is just before JMeter latest, which is a Docker image on Docker Hub. I'm going to fast forward now to the end of the JMeter test run. That didn't take too long. We've used JMeter to simulate traffic to our website. Let's go and view that website. So I'll go to the prod site. Now if I go to the home page, you'll see 3% here, but I haven't yet refreshed. So I'm going to hit refresh here to refresh the prod site. Now you'll see that we're still getting 3%. That's because I'm being routed to the prod slot, which is 3%, rather than the blue slot where we've deployed the new version of the application with the 6% discount. Fortunately, I can force that by using this XMS routing query string to force a routing to a named slot. In this case, my slot is called blue. If I do that, you'll see that I'm on the new version of the code, which has the 6% discount. Let's go over to the Azure portal. Again, this is the state of the Application Insights telemetry before we deployed the new version of the application and ran the load test to simulate traffic. So let's refresh this dashboard. That looks good. We're seeing telemetry from the 10038 version of the application, which is deployed to the blue slot. Looking at the blue-green oil breakdown, we can see that only though 20% of the traffic is going to the blue slot, we have a higher number of sales in the oil category. So it looks like increasing the discount definitely increased the amount of sales we were getting on our site. In this case, business would be able to determine with data that the experiment is successful and their hypothesis of increasing the discount yielded higher sales. Let's go back to the pipeline to finish it off. You'll see there are two environments pending an approval. The full deployment, which just does a slot swap, putting 100% of traffic onto the blue slot, which becomes the new production slot. There's also a rollback, which does the traffic manager swap, taking 100% of the traffic to the current prod slot. It doesn't even need to do a swap. And that's our way to roll back. Since our checks passed and our hypothesis was successful, let's approve deployment to the prod slot. that's going to queue that job and run through. In the next video, we'll look a bit deeper at application insights.